Our test car has a speedometer, an RPM gauge, and an engine that explodes at 200 RPM. Let's push it to its limits. It reached the maximal speed of 16 kilometers per hour in 8 seconds. Can we get better acceleration, better maximal speed? Let's study our engine. The gear attached to it exerts a certain amount of force. This force can lift 20 kilograms, but not 40 kilograms. We will now demonstrate how a few additional gears can enable us to lift 40 kilograms. A visualization trick will help us choose the right gears. This orange flare represents energy. To be more precise, let's mark the distance our force crosses in 1 second and multiply this by its magnitude. This is our engine's power, the amount of energy it unleashes every second. At this RPM, the power is about 40 watts. Power is transmitted from gear to gear. Assuming no friction, all 40 watts reach the last gear and it exerts the same amount of force. In this arrangement of gears, the last gear's teeth are moving slower. Since energy cannot disappear, our 40 watts will now produce a double amount of force. A gear ratio of 2:1 creates this effect. In our car, the engine's power is transmitted to the back wheels. Each wheel gets half of it. The force exerted by the wheels accelerates the car. Our new car has a 2:1 gear ratio in its gearbox, doubling its acceleration. Let's compare the cars. We'll visualize power, but this time show the amount of energy produced every 1/10 of a second. This is now 400 watts. Eight kilometers per hour in 2 seconds. That's better acceleration, but worse maximal speed. We can rearrange the gears to get the reverse effect. Less force, more speed. Our final car has a gear stick, allowing the driver to switch between low gear as in the second car, medium gear as in the first car, and the new high gear. "16 kilometers per hour in 6.5 seconds. "32 kilometers per hour in 23 seconds.